All right. Welcome back to Galata's Academy. We've been away for some time, but now we are going into a new concept. And this new concept is basically to help students preparing for UTME. All right. So, what this concept is all about? So, we are actually treating concept-based lectures, right? So now, our today's topic is pinhole camera. Our today's topic is pinhole camera, which is under what? Light and physics, right? So these are just like short lectures which are meant to bring you up to speed on a particular concept. And we've chosen pinhole camera. As you know, I love interactive lectures. I love interacting with our students. Now, what do you understand by pinhole camera? Like, when I hear this name, what comes to your mind? All right, drop it in the comment section right now. All right, so now, just like every other lectures, there's an outline for this lecture. First off, so we have to know the meaning. What's the meaning of pinhole camera? What the fuck is it? So now the characteristics. All right, so we have to know the principles. The principle behind the pinhole camera as a whole. Also the users. And the most importantly, we treat questions, right? Questions. So I won't dwell much on this. I'll just give you hints like the concept you need to know, what you need to know, and then we'll just move on, right? So we'll dwell on this, right? And know that this is UTME based, right? UTME based, WAEC based, WAEC 2 applies. WAEC applies. All right, so it was UTME based. Okay, let's start. Now, what do you understand by pinhole camera, right? So pinhole camera, first off, is a camera. We need to know it's a camera. And it's simply a camera with a pinhole. Funny, right? But that's it. Now, formally, right? A pinhole camera is a simple low-tech camera that uses a tiny aperture. This tiny aperture is what is known as a pinhole, right? It's what's known as a pinhole to project an inverted image. So we know that what is projected here is an inverted image, right, onto a surface inside the camera. Now, I don't like a lot of text. I like being practical enough. Let's assume a guy is standing here, and I'm basically using a pinhole camera, right? I'm basically using a pinhole camera. Let's get the concept right. So this part, as the back part of it, is actually what is reflecting the light. Exactly, it's reflecting light. That is, it captures the light. So these are pinhole camera, right? So from here it goes here, right? And from here it goes here. Now, if I'm to take out this film, this is how it look on it. Is that very clear? Now, this is an inverted image. This is an inverted image. So, what are the characteristics of this pinhole camera or the image produced by a pinhole camera? What are the characteristics? All right, you have to understand that first off is that the image produced is inverted, right? Number two is that it's smaller, right? It's smaller in size. Is that clear? It's smaller in size, and the image can be used in analysis of the rectilinear propagation of light. Now, one of the characteristics is that it actually exhibits the rectilinear propagation of light. Now, what does this mean? When you hear rectilinear propagation of light, what comes to your mind? It's very simple. Rectilinear propagation of light actually talks about the transmission of light on a straight line, right? visual line or a straight line. That's why I can find out that when I was drawing this line, I didn't, it wasn't a wiggle line. It was an absolutely straight line. Exactly. So that's simply what the retinal projection of light is. Now, what are the principle of pinhole camera? What happens? Now, there are several principles of the pinhole camera, but what I'll be teaching, the concept I'll be talking about here is simply, well, the concept I'll be talking about here is how it's the kind of question they can ask, right? I'm going to teach only what they will be able to ask in the exam. Is that clear? Now, the principle of the pinhole camera is that one, it needs long exposure of light, long exposure of light to capture an image. Exactly. Unlike the normal camera which we normally use, milliseconds is enough. We just have to focus on the object we want to capture and then click, press click, and it captures it. But here in pinhole camera, it requires a long exposure to light. Also, the size of the hole matters a lot. It has to be pin really, really small in millimeters, right? In millimeters. Now, what happens if we increase the size of the pinhole camera? We are going to obtain a blurry image. A blurry image, because the principle is that this pinhole camera, this large hole, is made up of little pins, meaning that there will be an overlapping of the images, right? Remember, it travels in a straight line. There will be an overlapping of the image, producing a really, really blur image. Now, the smaller the pinhole camera, the more the sharpness of the image produced, the more the sharpness of the image produced. Now, that means to say, if we increase the pinhole camera, the sharpness decreases. Is that very clear? All right, so do not forget that. Now, what are the uses? Let me clear this space for, yeah. What are the uses? Basically, there are uses, but most times I'm going to speak from the olden days. It's used to monitor or for safe observation, right? For safe observation of the solar eclipse or the solar eclipse. That's one of the main functions. We can't look at the sun directly. Yeah. So this is actually used for safe observation of the solar eclipse, and it kind of makes sense because since it requires long exposure, we can actually use that, right? Also, it's actually used to capture the movement of the sun over a longer period of time, right? So to capture the movement of the sun over a long period of time. Over a long period of time. Exactly. And they are also used in for artistry work. They're also used by artists, right, to get a more like a mosaic form of image, right? After they obtain the film, they will now work on that model. Is that clear? Also, they can be used in also the photography industry, right? Schools of photography, right? To teach students the principle of the camera, right? So, school of photography to teach students to teach students, right? The everything. Okay, now let's treat some questions. So here's our first question of. All right, so here's our first question of the day. What is the effect of the increase in size of the hole of a pinhole camera? Increase in size of the hole, right? Increase the size of the hole. Now, without even looking at the options, I expect you to know this. And what was it? It gives a blurry image. I told you, I explained it, that if we have a large hole, it's just in sense limited of having several little holes. So if this was a film, what do you think will happen? There will be overlapping of images. Overlapping of images, meaning that where we will not get a sharp image. Is that clear? Is that clear? All right, so it gives a blurred image. So why other one is wrong? Someone say correct chromatic aberration. No, chromatic aberration is different. What they say chromatic aberration? First of all, let's break it down. This is very simple. Chromatic means color, right? So it means color correction. Aberration means like how like something different from the way it normally is. So correct color damage. Let me say aberration here can mean color damage, right? Is that what it's used for? Definitely not. So this is wrong. Magnifies the image. This is wrong. Brings the image into sharper focus. This is also wrong. So this is the only correct answer here. Gives a blurred image. Now the second question, the image. This is number 2 question. Okay, the image in a pinhole camera is what? You don't even need to look at the option here. Just go straight, select the answer, and move on with your life. All right, so now the image in a pinhole camera is one. Is it erect? It's not erect. Is it virtual? No. Now, I'm going to explain this virtual image for you, right? Virtual and real image. How to like put it through to what the concept is even all about. Exactly. Now, erect and get sharper as the whole becomes larger. Erect, definitely not. Inverted? I said that. Formed by the image from each point traveling in a straight line. This is true. So the correct answer is B. Now, like, how do I know? First off, I explained to you using a guy, a person standing. So when we have a line traveling a straight line like this, so we're supposed to get something like this. Is that clear? Inverted. Now, this is inverted and formed by the light. Yeah, it's formed by light traveling in a straight line. Rectilinear propagation of light. Rectilinear propagation of light. Exactly. Now, when they say virtual and real image, what exactly do they mean? What exactly do they mean by virtual and real image? Now, if an image can be projected on a surface, that is a real image. But if it cannot be projected on a real, on a film or on a surface, then it's a virtual image. I will explain this in details when I come to lenses, right? That should be our next topic. So stay tuned. Is that clear? All right. So let's move to the next question. Now, as an object moves towards the pinhole camera, the image becomes what? If just the concept of your phone camera here. Now we have this thing, we have an object here, and we have an object here, right? This we know will be here, but this will be bigger. You can see it's not covering everything, so it will like go down, like really go down, right? So you can see the difference here. Can you see? Meaning that if we get an image closer, what are we expecting to get? All right, we're expecting to get a larger image, and a brighter image. Exactly, making E correct. Now, others are really wrong. All right, let's move on. We have no, I want to put this. So if the size of the whole of the pinhole camera is increased, the image form is what? Is blur, first off. Is blurred and what? Okay, if the image of, sorry, let me just get this right. It becomes blur and brighter. Exactly, blur and brighter. Okay, The pinhole camera produces a less sharply defined image when what? A less sharply when the pinhole camera is large. It's as simple as that. All right, let's move. Okay, question. All right, question. So, an object 2 meter high, an object. So now, after writing, I will give you the formula. Right? Let's write the parameter first. The parameter. All right. So object height is 2 meter. Place that the object distance is 5 meter. If the image height, so image height is 4 cm. What is what? The image distance. Now, it's very simple. This is the formula. Image height over object height equals the image distance over object distance. It's as simple as that. Okay? Now, there's something we have to do to correct before getting our answer, right? You can multiply, you can just convert this to meter. After getting answer, you convert it back to cm. Exactly. So this would be 4 times 10 raised to the power minus 2 meter. Now, remember that centi means you're going to divide by 100. You're going to divide by 100. So instead of me writing divided by 100, just like, okay, 1, 2, this like times 10 raised to the power minus 2. But just try to put things easy. So we have 4 times 10 raised to the power minus 2 over object height, that's 2. Because the image distance is x, we don't know that. Oh, I think what's distance from the film? So image distance, yeah. Image distance is unknown. Okay, object distance is what? 5. Cross multiply. Okay, we have 4 times 10 raised to the power minus 2 times 5 divided by 2 is equal to what? X. So 2 here, 2, 1, 2 here, 2, 2 times 5 is 10. So 10 times 10 raised to the power minus 2 meters. Exactly. So now, in order to get our answer, how do we get it? How do we get it? We simply what? To convert meter into centimeter, what do? Times 100. To convert centimeter into meter, we divide by 100. So to convert meter into centimeter, we times by 100. So this will cancel this. They basically mean the same thing. Or let me just put it through. Let me not rush. Skip steps. I want you to really understand this. Is that clear? So minus 2 plus 2 is what? 0. So 10 plus 0 is 1. So this was 10 cm. What answer here? C. It's as simple as that. Okay, next question. Now pause this, right? I want you to pause this question and solve it on your own, right? And then get back to it. All right, so let's go. A boy 1.2 meter tall. So a boy, this is object height is 1.2 meter. Stands 3.6 meter. So object distance is 3.6 meter. You know the pinhole camera. If it's image, so the image, right? If it's image screen is behind, so image distance is 30 what? cm. Please, I want you to take note of something of the SI unit. Yeah, a lot of questions you see in JAMB are really very easy, right? But if you don't understand the concept, you are not smart enough, you just fail it. Something you know. Exactly. All right, so calculate the height. Now, we're asked to find the image height. Now, what's the formula again? Image what? Height over object height equals to image distance over object distance. Image height is what? X. Object height is what? 1.2. Image distance is what? Remember, we times 10 raised to the power what? Minus 2. This will cancel out. Is that clear? So this is actually an interpretation of this. So C here stands for 10 raised to the power minus 2. Exactly. All right. So image distance is 30 times 10 raised to the power minus 2 over object distance is what? 3.6. All right, let's go. Right, so we have let me start from here. 30 times 10 raised to the power minus 2 times 1.2 equals divided by 3.6 equals x. All right, so I would like to, like, I can just go this like just straight, but then you just take it step by step so that everyone will understand. Times 10 times 2 times 12 raised power times 10 raised power minus 1. How I got this is that I move this forward. Exactly. Meaning that if I want to get back to this, I have to go back once. Exactly. 1.2 times 10 raised power minus 1 means I have to just 12 times 10 raised power, I have to just go back once from here. Remember, all integer is just 1.0, 2.0, so this is not excluded, so it's like 12.0. So I can just go back one to get 0. I don't know. So this 36 times 10 raised power minus 1. I hope you get the gist. All right, so this will cancel this. 12 here 1, 12 here what? 3. No, this 30, 3 here 1, 3 here what? 10. All right, so we are left with 10 times 10 raised power minus 2 meters. Now to convert to centimeter, what do you do? Just multiply times 100, right? Or times 10 raised power what? 2. This. What's your final answer? 10 cm. What's it there? Yeah, it's as simple as that. As simple as that. All right, so we still have one more question to go. All right, so a pinhole camera is placed at 300 meter in front, 300 meter in front of a building. So this is the object distance. Do not forget. The way you interpret a question matters a whole lot. A whole lot. So that the image is formed on the screen 5 centimeter from the pinhole. So this is the image distance, 5 cm, which is equal to 5 times 10 raised power minus 2 meters. All right. Okay, so if the image is 2 centimeter high, so image height is 2.5 cm. We have 2.5 times 10 raised to power minus 2 meters, right? The height of the building. So object distance is x. Now go back to your formula. Simple as that. Image height over object height equals to image distance over object distance. Yup. All right, so we have 2.5 times 10 raised to power minus 2 divided by object height. We don't know object height, yes. So image distance, 5 times 10 raised to power minus 2 divided by object distance, 300 meter. Easy peasy. So we have 5 times 10 raised to power minus 2. Is that clear? Times x. Yeah. Oh, I don't skip step. This might be the last question, so let me just take my time. All right, so divided by 5 times 10 raised to power minus 2. 5 times 10 raised to power minus 2. This cancels this, right? So we have x equal to this. We cancel this, remember? From here, yeah, you get? Okay, so 2.5 times 300 divided by 5. All right, so this can we go back to 25 times 10 raised to power minus 1. I've explained the concept to you, but if you don't understand, signify in the comment section that you do not understand, and I'll create a separate video to teach you how to treat questions on indices. All right, so this 5 here 1, 5 here 5. So 5 times 3 is 15. Add your zeros. Exactly. Remember this. So just go back once. So our answer is what? 150 meter. Is that clear? So this is our answer here, which is D. Easy peasy. All right. So we've come to the end of this lectures. Very short. Do not forget to subscribe. Ensure you subscribe. Ensure you follow. Ensure you comment. Ensure you interact. Ensure you share with your friends. We are grateful. Have a great day ahead. Bye.